think let's dive straight into some useful definitions, things that I think it'll help clear up a little bit about what all these different terms mean. And one that might not be such an obvious distinction, but is worth thinking about, is data science and machine learning. And data scientists for a number of years now have been in super high demand. I've spoken to numerous banks who are constantly trying to get their hands on data scientists with experience, and then you find there basically are no data scientists with experience available, and if they are available, they are incredibly expensive. But there's been a rise of something called a machine learning engineer as well, which are the people who can actually implement these models and make them run as part of your business and build these new machine learning models. And I think a key thing to think about here is sort of the output. So when you think about data science, it's essentially the interaction between mathematics and business knowledge and computer science, all pulled together with the idea of taking your data and getting some insights from it. And then they quite often tend to output a slide deck, so some document or material that management can then use to make decisions. When we think about machine learning, it's very much about getting machines to learn what the answers are themselves. So working directly from the data and then creating a system or a process that can then make decisions and use that information, insight from the data, to then help improve our business processes or automate some of the decisions that we need to do over and over, or sometimes even make decisions better than we would be able to, because we can't always process all the data that the machine can look at. I think a key thing, if you're reading about AI, for those of you who follow the news, who see information about startups or businesses implementing AI, it's quite helpful to know these distinctions between artificial intelligence, machine learning, and deep learning as well. And you'll quite often see people using AI when they actually specifically mean deep learning. You'll see all three of these terms used very much interchangeably. So let's go through a little bit what each of them means. So AI has been around for a long time. And I think I mentioned yesterday that you've basically had decision-making machines that they dug out of the ocean, which date back potentially thousands of years, which are mechanical, and they use sort of gears and things to help predict seasons and that type of thing. So that, in essence, is a very simple form of AI. And broadly, AI is any system that can let a machine mimic human decision-making. But what we're more interested in these days is machine learning. And that's rather than having someone asking an expert, what are the rules for pricing a house? And the expert might tell you, you take the number of bedrooms and multiply it by a factor for the area, and you add this much if it has a swimming pool. Machine learning instead just looks at the data itself, and from the data derives what the rules are. So you don't need to program it, and if the situations change and circumstances change, those rules can also update themselves. When you go to deep learning, that's really what's been driving the progress over the last 10 years, why AI has become so hyped up. Because as we gain more and more computational power, more and more data, deep learning, which is modeled on the way that, to some extent, it's modeled on the way that the human brain works. So that's why they talk about deep neural networks, sort of layers and layers of little nodes, which we call artificial neurons, and they work together to then make a decision. And to some extent, I think this is has some similarity to how we think as well, although I think the two are divergent in many ways. A little bit about deep learning. So something to think about here, I mentioned that it's been successful lately because of the increase in data and the increase in processing power that's become available. And people have heard about Moore's law, so that same equation has been driving progress in AI. So much so that where, say, 10 years ago, AI was quite fringe, and actually even companies like Google and Baidu were quite skeptical. And a chap called Andrew Ng drove a lot of the progress in those organizations and really brought AI to the forefront. These days, you actually find deep learning systems all over. So when you're using a browser and it makes recommendations, when you're shopping on an online shopping website and it's saying that these things are frequently bought together, when you're using a new iPhone and it's able to log you in by looking at your face, or you're using the voice assistant, all of that is driven by deep learning. And we're going to see this appear more and more with smaller and smaller devices being able to run deep learning systems. Just one point on that graph we have there. So when you have a person, say, let's say a small child, say 5 years old, and you show her a picture of an elephant, Based on that one example, normally you'd be able to get him or her to look at a bunch of animals and tell you which one is the elephant. So that's a very small amount of data that we as humans are able to learn from and perform very well on. It's the exact opposite with especially deep learning, machine learning in general, but deep learning. Deep learning is not able to do much when you have one example or even 10 or 100 examples. But as you get more and more and more data, eventually deep learning actually starts to outperform not just regular machine learning, but also humans. So we've had cases where deep learning is now better at certain image recognition tasks, for instance, including some in the medical domain, than even a panel of experts looking at, say, an X-ray together. That does assume that you have very high quality X-rays going in and lots of other caveats, but the more and more data grows, the better deep learning's capabilities are getting. And this is a trend that is not stopping. The rate of data is growing in the world is phenomenal. So we will see this trend for deep learning making better decisions than humans continue over time in more and more complex domains. So I have a little picture here of a neural network. You can see the neurons there. I'm not going to go into this in detail today because I think we've got some more interesting things to touch on. But essentially, this network will learn from a lot of data and eventually be able to do something like take a picture as an input and tell you that this picture is in fact a dog, but not some other class of object. And you obviously use a lot in object detection, computer vision, and self-driving, etc.
Renier, I am curious. This schematic diagram of the neurons, where does that normally reside? Is that a special computer? Has it got to be a massive computer, or you know, what would the hardware look like?
Okay, so that's an interesting one, and actually the one of the things that's been driving deep learning progress has been what we call GPUs, so graphical processing units, which were made for playing games. But because the way they're structured, they're able to do so many things at the same time, so many small tasks. We have been using GPUs more and more, and even building like Novia especially has been building special GPUs that are designed and optimized specifically for deep learning applications. But that said, you could run a deep learning system on your laptop. The GPUs make it go a lot faster. So I'm sitting with a massive, essentially a gaming desktop next to me because it has the hardware that I need to train deep learning systems. But you could run it on even small computers. And these days, I mentioned that they're being integrated into smartphones. So you would train this model on a really big computer with lots of GPUs potentially. But once it's trained, it becomes easier to run, and you can run it on smaller systems. You can there's some techniques that you can create smaller versions of a model that can be ported to cell phones. But in essence, all of this lives in code, and you can use any type of processor or computer to execute the training cycles. And it's basically just mathematical operations that are run over and over and over. Perhaps you have 1 million examples and you run through that 1 million examples several hundred times. And then it goes through each of these little nodes in this network and it adjusts their weights so that it gets to the right answer using some calculus in the background. So it's not particularly complex hardware that you need, but it is quite a lot of operations that need to be done. And if your hardware isn't strong enough, then it could take days to train a network. These days, we seldomly train anything in practice that wouldn't be able to run overnight or so. But in academia, the guys that are really pushing the limits might have models that take weeks to train. But yeah, it's pretty normal stuff. There's no special computer that you need to do deep learning. Your in-house developers at your companies would be able to do it on their computers, or potentially you could buy a custom computer that gives them some more firepower to do this faster and to iterate more effectively. A little bit more technical distinction, but I ask everyone to bear with me because this is quite useful for thinking about use cases and thinking about ways that it can be used. So the definitions between supervised and unsupervised learning. In most deep learning that's happening at the moment is, and historically has been supervised learning. So you have an input and you have an output, and you give both to the computer, and it then learns how to get from the input to the output, and eventually you can give it a new input and it can give you the appropriate output. So examples would be you give it lots of audio and a list of transcriptions, And then after a while, it learns how to transcribe, and then you have a speech recognition system. The other things would be like translation. So if you have lots of sets of English text and French text, it can learn to translate from the one to the other, and you can give it a new sentence, and it should be able to give you some degree of accurate translation. This has actually gotten a lot better with deep learning in recent years. Same thing with detecting spam. I mentioned X-ray diagnosis. This is something I find very interesting, but reading X-rays, MRIs, sonars, it requires a lot of labeled data. So you need to actually have the X-ray, and then you need experts to annotate it, to say, well, this is a perfectly healthy lung X-ray. This next one, we see some sort of fluid in the lungs. Perhaps I'm not an expert in reading X-rays, so Ty is probably laughing at me. But you need many examples, like tens of thousands of those examples that have been annotated, which is quite an expensive process. And then the machine will learn how to do that very accurately. My favorite one on here is Domino's Pizza, which actually has, in some countries, in some of their branches, they use cameras, an AI system, to look at each pizza which leaves the oven. And it checks, is the pizza cooked correctly? And does it match the order of the client? And if they put on the wrong toppings, or if the client asks, no olives, and there are olives on there, it'll alert the team and say, hey, no, you can't send out this pizza, we need to redo it, you need to keep the customer happy. And that's quite a fantastic customer service application, because you can extend this to lots of other areas and domains, and make sure that you're actually doing what the customer asked for by just having an AI compare what was asked versus what we're about to deliver. On the unsupervised learning side, so this is in some senses quite exciting and also very hard, but there are a lot of established techniques for this, and it is something that sees results. And these are cases where you don't have the labels. So you have a lot of information. Let's say you have a lot of information on your customers, and you think, well, I've probably got different categories of customers. We seem to be getting a lot of inquiries from sort of young urban people. We know we have some customers in rural areas, but we don't really know what these profiles look like in a lot of detail. Can we get the machine to tell us? And yes, absolutely. You've got a lot of what they call clustering or segmentation algorithms, which can take that data and find the natural groupings within it. And then it can give you these groupings, and you can say, oh, okay, I see there's a group of, say, young urban women who are very fond of our brand. But strangely, we also have a group of rural males near retirement. And then you can start thinking, well, actually, maybe I need to tailor my marketing a little bit and double down on reaching these markets. Or you might realize that a market segment that you thought you were doing well is actually slightly differently defined, or is absent from your set. And the little image I have there is in 2 dimensions, but realistically, you'll be doing this over a lot of different data and many dimensions. And there are actually even still then some ways to visualize it, but it becomes a lot harder. But the unsupervised learning, we'll go into some examples, because it's not necessarily as obvious how you would use it, but it does provide some powerful ways to get started with machine learning, even if you don't have large supervised labeled data sets like you would need for supervised learning.